VLSos here. This is a video lesson on arithmetic series. Let me show you an arithmetic series. 2 plus 2.5 plus 3 plus 3.5. We could imagine that there's a pattern being followed, but it stops at a last term value of 6.5. This is arithmetic because there is a rule which determines the values of these terms. And the rule involves addition, specifically addition of 1/2 each time. Arithmetic because the rule involves addition. But it's a series because it's not only a pattern of term values, but those term values are being added together and later can produce a sum. And the rule, or the constant difference, is 1/2. So we have notation to express term number 1. If the initial term is term 1, then its value is 2. We also have a last term, but it may not be obvious what term this is, what term number. We might have to count. If we count 2, 2.5, 3, we would count 10 times to reach 6.5. So we could say term number 10, or t sub 10, is equal to the value 6.5. And n, the number of terms in this series, is equal to 10. We have 10 numbers to add together. Now, how do we produce that sum? Well, from a previous lesson, we could use capital S to stand for sum. And if we put a 10 next to the S, we read this as S sub 10. But what we mean by it is, what is the sum of the first 10 terms of this series? And if this series only has 10 terms, then that's going to be all of them. Well, adding up those numbers would be helpful with a calculator, but even a calculator would be quite tedious. There is a fast way to think about the sum of an arithmetic series and do it quickly. And to understand the formula that we'll get to do that for us, let's get an idea, a visualization of what we're adding together. I'm going to make a bar graph. This will be term number 1, and the height of the bar will be the value of that term. So term number 1 has a height of 2 because its value is 2. Term number 2 has a height of 2.5. And this is going to follow a trend. We have 3, 4, 5, 6, 7, 8, 9, and 10 terms. It's going to go up by 1/2 each time. The last bar has a height of 6.5. because the value of the last term is 6.5. Let's think about adding all of these together. What is the sum of all of the heights of these bars? It follows a pattern. If I take this longest bar and I put it on top of this 2, then it will be 2 plus the 6.5. Or I could show that to be a single bar that has a height of 8.5. If I were to put this longest one on top of the shortest one. If I put the next tallest one on top of the next shortest one, it would be a 6 plus a 2.5 and have the same height. In other words, I could keep doing this. I could take the top half of the tallest bars and match them with the bottom half of the shortest bars, and each time they would make the same height. It would also create a rectangle. Rectangle areas are easy to calculate. It's simply base times height. This will always work with an arithmetic series. I can always take half of the higher values and put them on top of the half of the lower values to create a rectangle and find the sum of them all by multiplying base times the height. This rectangle has a base of 5, and it has a height of 8.5. I found the height of 8.5 by adding the lowest value 2 to the highest value 6.5. And I found the base of 5 by taking half of n, the number of things we're adding together. So S sub n, the sum of these 10 terms, is going to be equal to 5 times 8.5 in this case, and that is 42.5. But we can generalize this. We can find, given an arithmetic series, the sum of any n number of terms of that series. In general, what we do is we take half of the numbers that we're adding together. If n represents the number of things we're adding together, half of it is n divided by 2. And we then multiply by the sum of the smallest term and the largest term, or the first term and the nth term. N is where we're stopping. This is a general formula that will always work. It may be helpful to know how we get that final t sub n term. If this is an arithmetic sequence, then the value of the nth term is the value of the initial term plus the constant difference times 1 less than n number of terms. These two are formulas to find the sum of n terms or the value of the nth term. They will always work, but only for arithmetic sequences and series. For example, what if we were working with the series 11 plus 18 plus 25 all the way up to 74? Is this arithmetic? Well, then it would increase by a constant difference. 11 plus 7 is 18, plus 7 is 25. I'm convinced that this is an arithmetic sequence or series with a constant difference of 7. We also know the value of the first term. That's equal to 11. And we know the value of the last term is 74. But we don't know how many terms we add up to get 74. We could count, we could show them all, but there's a clever way to do it. If we know this is arithmetic, we can use the formula for the value of the nth term, dependent in this case on the 7, or the value of the first term, which we already know, plus the constant difference of 7 times n minus 1. And we know the value of the last nth term to be 74. So if we set an equation for it in terms of n, we can solve it for n and know how many terms we need to go to get to the last term of 74. In this case, I'm going to solve this equation for n by first subtracting 11 from both sides. Then divide both sides by 7. And then add 1 to both sides. It takes 10 terms to go from 11 up by 7 each time to get to 74. So with that, the sum of this series is going to be the same calculation as S sub 10. And the formula for it is going to be n divided by 2, or in this case 10 divided by 2, times the value of the first term, or 11, plus the value of the last term, or the 10th term, in this case, 74. Or 5 times 85, which is equal to 425.